In this tutorial video, we'll be looking at how to set up and debug data in DataKit. First, we'll need to jump over to the DataKit setup asset. So let's do that now by going to the menu and selecting Game Object, DataKit, DataKit Setup. The DataKit setup asset is now visible in the inspector, and we are currently in the Local Data tab. When saved at runtime, everything that exists in local data will end up becoming a save point. This is what we typically use for tracking a player's progress throughout a game. Currently, the local data screen is organized with information about the default local data group and two local data groups that I've already set up. The default data group offers a way of shortening our code by not having to use the group parameter in the API. It also creates dynamic example code which you can copy and paste, but we'll cover this more in a scripting focused video. For now, let's take a look at our first local data group. If we open it, we'll notice that the group's name is called Player. This would be a good place to store all of our player specific information. I've already set up a list of data keys that will be tracking the player's name, level, experience, and gold. I can easily change the name of a key, its data type, and its default value. I can also reorder my data keys with these arrow buttons. I can remove keys with the remove button and undo any changes I make. If I try to create a new key, you'll notice that the default data type is a special type called unassigned. This tells DataKit that even though a data key exists, it doesn't have any data yet, and can loosely be considered as empty or null. You can also use custom classes, arrays, and other collections by using the custom data type. Even though DataKit should support any custom class or collection as long as it is public and consists of supported data types, it's worth noting that it isn't possible to edit its data directly in the editor. Lastly, if we open the code snippet section, you'll see that DataKit dynamically created real scripting examples using the actual names of your groups and keys. You can also easily copy and paste these snippets with the copy code to clipboard button. If we want to add more data groups to our local data, this is easy to achieve. We simply click the plus button in the bottom right and a new data group will be created. We also can delete any data group by pressing the remove button in the top right of its layout. Let's switch to the Global Data tab. You'll notice that the Global Data screen looks almost identical to the Local Data screen. This is because setting up Global Data uses the exact same workflow as before. The only difference here is Global Data is used differently. Global Data is always persistent, which means any save slot and save point will always be using the same version of Global Data. This is specifically good at tracking things like in-app purchases or game settings. In fact, we have some example game settings set up in a data group right here. As we already know how to set up data groups and keys, let's move on to the Options tab. This tab allows us to customize how DataKit will work within our game. The first option is to select a storage mode. For almost all use cases, we should use local files, which is DataKit's default way of saving data. This allows you to use larger save files and is far better for performance. If you're using a build which cannot save local files, such as WebGL, you could choose to use the player prefs mode. You should note that when using this setting, all of your save slots and save points will need to collectively fit inside of Unity's 1 MB limit. For now, we'll use local files. The next option is save slots. Save slots tell DataKit how many separated groups of save points we want to use. You can think of this as different players, different accounts, or maybe even different characters within the same RPG. How you use save slots will largely depend on the kind of game you're making. It's worth noting that even if we disable save slots, DataKit will technically still be using one under the hood. You just won't need to worry about them. Next is save points. By default, every time we tell DataKit to save, it will make a new save point out of the current local data. This gives us a history of save files that can be loaded. If we disable save points, DataKit will actually be using a single save point under the hood and continue to replace the same data over and over again. The next option here is auto replace old save points. This tells DataKit that when a user exceeds the maximum number of save points, it should automatically delete the oldest one to make room. Finally, we have a slider allowing us to set the maximum number of save points. To optimize performance across platforms, DataKit has a maximum of 100 save points per save slot. Next, we have initialization options. When DataKit is setting itself up for the first time, it will eventually try to load the latest version of global data, if it exists. In addition, we can set up DataKit to load the default local data that we've set up in the local data tab, or try to load it from the newest save point in a specific save slot. We then have the groups and keys options. By default, DataKit allows you to easily create new groups and keys from the API without checking if they already exist. If they don't, DataKit will automatically create them for you, which is similar to the way Unity's player pref system works. You have the option of turning off auto create groups and keys to make sure that keys and groups cannot be created unless it is done specifically in the API. We recommend leaving this turned on as it makes scripting easier. Next, we have auto save descriptions. This allows us to set up some text to automatically appear before and after a custom save game description. This happens whenever we save local data with the autosave method in the API. By default, DataKit simply adds autosaved in brackets after the custom save point description. The next set of options revolve around screenshots. Whenever we save our data, we can have DataKit automatically capture a screenshot to be used as a thumbnail in our own UI. We can set up the size of the screenshot and its quality to balance how much disk space is being used, as well as being able to set up a custom placeholder image when a screenshot isn't available. Next, we have performance options. If we're working on a VR or mobile title, we may choose to try and prioritize frame rates over file speed. We can do this by purposely slowing down DataKit's asynchronous methods to help you balance things. In addition, we can slow down data caching when loading data, in order to get smoother gameplay at the expense of file speed. Finally, we have debug options. Other than being able to toggle console messages about saving, loading, deletion and the save point map, we can use DataKit's preloading feature by enabling preload DataKit in editor. This is on by default and allows us to test the game with our data preloaded before the scene even starts. All we need to do is press play in the editor and DataKit automatically handles the rest. Now let's move on to the Encryption tab. In this section we can choose to enable obfuscation or encryption of our game data. Before moving forward, it's worth noting that DataKit saves its data in a format that is quite obfuscated to begin with. What we're doing here is adding further obfuscation to the data. Generally speaking, if you don't need crazy levels of obfuscation, it's generally recommended to leave this turned off, as this will have an impact on DataKit's performance during file I/O. If we want to enable it, we have a few options to choose from. We can use AES encryption or XOR obfuscation. XOR is the easiest to set up as there is nothing to add. It is also much faster than AES, so it's a good choice if you want to add another level of obfuscation to your data. If you want to go all out, you can choose to use AES encryption. This requires a lot more setup as we need to provide an encryption key as well as a password. The default key is hidden by default, but we can show it using the show button, revert the key using the use default key button, or generate a new key by pressing the generate new key button. We can continue to create new keys by clicking the generate new key button. A new one will be randomly generated each time. For a less secure but more friendly way to use AES encryption, you can use the default encryption key, as that will ensure you can never lose it. You must then supply a password. A random password can be generated, or you can use the default. It's important to remember that if you lose or change your encryption key and password, you will not be able to access your saved data. Needless to say, you should absolutely never change them after your game has been released. If you're not using encryption, DataKit allows you to strip the entire encryption codebase out of your project completely by using a scripting define symbol. To do this, we can go to player settings and add DataKit encryption off in the scripting define symbols text field. After the scripts have recompiled, we can go back to the DataKit setup asset to find encryption removed. We can add encryption features back into the game by simply removing the scripting define symbol. When Unity finishes compiling the scripts, the encryption options will again be visible. When you're done in the Encryption tab, DataKit allows you to lock your settings with this checkbox. This makes the tab a little safer by dimming out the encryption UI fields to help prevent against any accidental changes. You can simply uncheck the lock options to restore control. Now that we understand how to set up our data, let's look at how we can use the DataKit debugger to view and edit our data while the game is running. First, we go to the menu and select Window, DataKit Debugger. You will notice that the debugger won't be available until we start the game in the editor. When we press the play button, you'll also notice the DataKit preloader feature kick in to prepare our data before loading our current Unity scene. The first thing you'll notice about the DataKit debugger is the local and global data tabs look very familiar, although there are some differences. This data represents the currently loaded data in memory and shouldn't be confused with the default data we set up in the DataKit setup asset earlier. You'll also notice that the values for data keys are not currently visible. We can only see the name of the keys and its data type. However, we can turn on real-time debugging on these keys by pressing the arrow button next to the key's name. I'll change the player's name to Mel, and if I want to, I can also change the name of the key. A cool feature is the revert buttons, available for all keys and groups. If I click this will change the value of the key back to its original value we set in the DataKit setup asset. If you remember, the default value for this key was player. We can also revert entire groups in the same way. I can delete a bunch of data keys, and if I press the revert button, the entire group will be restored back to its default setup. The global data in the DataKit debugger can be interacted with in the same way. It's worth mentioning that this scene is included with DataKit and offers a customizable UI system you can use as a template for your own games. We'll be using that here to create and load some save points. So, let's keep an eye on the data key for the player's name. Right now the player's name is player. Let's press the save game button to bring up the save UI. We'll give the save point a description called my name is player so we can easily recognize it and save the game. This will create a new save point of our current local data. It's worth mentioning that whenever you create a new save point, the current global data will also be saved automatically. Let's now change the player's name to Mel so we can make a new save point. We'll go through the same process again, but this time we'll name the description my name is Mel so we can tell the two save points apart. Now that we have our two save points created, let's try to load them back in by clicking the load game button. Right now the player's name is Mel, so let's try to load in the save point named my name is player. Sure enough, if we check the value of the player's name, it is now player. If we go back and reload the newest save point named my name is Mel, the player's name should now be Mel. Our save points are working great. To help explain how global data works differently to local data, we'll set up a similar test. First, we'll create a new data key that will store a color. We'll name the key myColor and set the data type to color. We'll then open the color picker and set it to red. Let's now create a save point and name it red global color. Now we'll change the color to blue and go back and create another save point. This time we'll name it blue global color. Now let's see what happens if we try to load the save point from when the global color was red. You may be surprised to find that the global color is still blue. This is exactly the difference between local and global data. There is only one version of global data. It is always the newest version, and it is always shared by every save slot and every save point. This is why it is good at storing game settings, tracking DLC, and other game-wide data. Now that we understand how to effectively work with data in the DataKit debugger, let's jump to the Save Points tab. The first thing that grabs your attention is probably the save points we created earlier. You'll notice that we're currently using save slot 1, and the save points we created earlier belong to that specific save slot. If we change to a different save slot, you'll notice that those save points are no longer available. Each save slot has its own list of save points, and this is what allows us to simulate different accounts or characters within our game. Save points can be loaded or deleted from the list, and we can even create new save points in the Create Save Point area. Let's test this by adding a description named My Save Point and pressing the little save button to the right. The new save point is now added to the list. Below that, we have access to some more powerful actions. We can easily revert local and global data back to the default settings using the top row of buttons. And we can also delete all save points in a save slot or all save points from every save slot. If we go ahead and delete all save points in save slot 1, all of our previous save points are now permanently deleted. You've now learned how to set up, view, edit, and debug your data in the editor. Thanks for taking the time to check out DataKit.